All right, class, settle in. Today, we're going to move from the pages of the textbook right into the clinic with a real diagnostic challenge. We've got a patient, we've got a list of symptoms, and we've got the lab results. Our job is to put all the pieces together by understanding one of the most amazing processes in the body, how we make blood. So, let's dive in. Let's meet our patient. His name is Kishan Lal. He's telling us he's constantly tired and gets out of breath really easily. Now, those are pretty general symptoms, right? But he gave us a huge clue. He's a strict vegetarian. I want you to file that little detail away, keep it in the back of your mind. You see, his blood is telling a story. We just have to figure out how to translate it. Okay, so before we can even touch Kishan's lab results, we've got to take a step back. We need to go on a little field trip to the factory, the place where this whole story begins. I'm talking about the red blood cell factory, located deep inside our bone marrow. Now, this whole process has a fancy name, of course. It's called erythropoiesis. But really, you can just think of it as a super sophisticated, non-stop assembly line. It starts with this one incredible type of stem cell, and what comes out the other end? Billions, literally billions, of these tiny, specialized oxygen delivery trucks we call red blood cells. So, how about we follow one of these little guys on its journey? We're going to watch it go from, a basic starter cell all the way to the finished product. It's seriously one of the most incredible examples of cellular engineering you'll ever see. Okay, so this journey happens in a few key stages. It starts out as this big, clunky thing called a proerythroblast. Then it goes through a few normal blast phases, where it starts to get its act together. Then it becomes a reticulocyte. Think of this as like a brand new car that's just rolled off the line, but it still has some of the plastic covers on it. And finally, boom, a matured erythrocyte, ready to do its job for the next 120 days or so. Now, look closely at this chart because there are two really, really important things happening here. First, see the cell size? It's shrinking. It goes from being pretty big to this tiny, compact little disc. And the second thing, and this is the real game changer, look at the nucleus. It gets smaller and smaller, and then, poof, it gets kicked out entirely. Now, why on earth would it do that? Simple. It's making room for the important stuff. It's maximizing every last bit of space for its precious cargo, hemoglobin. All right, so any good factory manager knows you need two things: quality control and a steady supply chain. Well, our body is the best factory manager there is. It has ways to tell this assembly line to speed up or slow down, and it has a shopping list of all the raw materials it needs. Let's take a look at how it pulls that off. The way the body regulates this is just brilliant. Think about it. Say you go climb a mountain. Your body senses lower oxygen levels, that's hypoxia. What does it do? Your kidneys shoot out this hormone called erythropoietin. You've probably heard of it as EPO. And that hormone is basically a message to the bone marrow saying, step on it. We need more oxygen carriers. And of course, the opposite is true. Certain conditions, like kidney disease, can mean that signal never gets sent. The production line slows right down. Okay, so what about that supply chain, the raw materials? Well, for this to work, you absolutely need these key ingredients on hand: protein, iron, vitamin C. And pay close attention to these last two, vitamin B12 and folic acid. Here's the takeaway. If you're missing even one of these, the whole assembly line gets messed up. It might slow down, or it might start pumping out cells that are, well, lemons, defective. All right, everybody with me? We've toured the factory, we've seen the assembly line in action, and we've checked the inventory. Now we're ready. Let's go back to our patient, Kishan Lal. It's time to look at the evidence. Okay, here it is, this smoking gun. This one number is going to crack the whole case for us. It's his MCV, which stands for mean corpuscular volume. All that means is the average size of his red blood cells. Now, a normal MCV is somewhere between 80 and 100. His is 115. So right away, we know his red blood cells are, well, they're big. They're way too big. This isn't just a random detail, people. This is the key. So what does a high MCV tell us? It points us directly to something called macrocytic anemia. And if you break down the word, macro means large, cytic means cell. Large cell anemia. This immediately tells us something went wrong on our assembly line. The cells started the process, they grew, but then something stopped them from maturing and dividing correctly. They're basically stuck as these big, puffy, immature cells that can't do their job right. Okay, class, time to put on your detective hats. Let's put it all together. Clue number one, we have these big, immature red blood cells, so we know it's a problem with cell division. Clue number two, and this is the big one, our patient is a strict vegetarian. So looking back at our list of essential raw materials, which one do you think is missing from the factory supply closet? If you said vitamin B12, you are absolutely right. The diagnosis here is megaloblastic anemia, and it's because of a vitamin B12 deficiency. See, vitamin B12 is absolutely critical for making new DNA, and you need to make new DNA if you're going to divide a cell into two. Without B12, the cells just can't split. They keep growing, getting bigger and bigger, that's where the megalo part comes from, but they never mature. And since vitamin B12 is found almost entirely in animal products, Keyshawn Law's diet was the final piece of the puzzle. And there you have it, case closed. I want you to leave today with this thought. The patient's entire story is often written right there in their blood. Every single number, every cell, is a word in that story. When you understand the fundamentals, the how and why of a process like erythropoiesis, you stop just seeing data. You start reading the language. Your job from this day forward is to become a fluent translator. All right, that's it for today. Class dismissed.